in this section, we're going to talking about vectors. So vectors is, as we talking about before, is a vector quantity having two parts, the magnitude and the direction. For example, I'm drawing one vector. Normally, we're using array to draw the vector, to representing the vector. So we have an initial point. For example, I'm going to label it as O. And then I have some endpoint. I'm going to label it as P, which is the end of my array. So this is an example of a vertex. From this picture, we can see we have a direction. We probably cannot describe it correctly, but we can maybe using the angle versions. Talking about, this is for example a 30-degree. So we can thinking about the direction is north 30-degree east. Another piece we will also have is the magnitude. How long is between the 0 to P? So that's the length of the vector, that is the magnitude. Not sure, but for example, I'm going to say the magnitude is 12 feet. So here I have a vertex OP. Vector OP have a direction and then a magnitude. Normally when we're talking about the magnitudes, we normally using the symbol, a bar and then OT between it. Is talking about the magnitude of the vertex vector OP. So it's kind of similar to our absolute value symbol, and then it's also talking about very similar things. If you're thinking about a positive number, like a 2, is talking about I have a real number line starting from 0. And then I'm going to the positive direction or the right direction by 2 units. Thinking it as a vector. Then a negative number, for example, -3, will have a very similar concept, that I have a real number line start from 0, and then I will go to the negative side or left side by 3 units. So when we're talking about the absolute value of 2, or if we're using the concept of vectors, we're talking about the magnitude of 2 regardless of direction. We have 2 units. So pretty much how many steps you're going away from the 0. If we're talking about the negative number, absolute value of -3, we're still using the same concept. How long away from 0 regardless the direction. So you can thinking about when we're talking about the magnitudes of a vertex of a vector, it's kind of similar concept as absolute value. However, when we're talking about vertex, it's not going to be that super clear. We normally need to calculate the length of the vector. We just talked about when we're talking about the magnitude of vectors, it's kind of similar in terms of the absolute value of a real number. Then when we're talking about vectors, then we can comparing them. So here we're going to talking about what do I say if two vector, or how can we say if two vectors are equal vectors? In order for any two vectors to be equal, they have to satisfy two conditions. The first one is they have the same direction. And then the second one is they have the same magnitude. So picture-wise thinking is I have two vector looks exactly the same with the same direction, with the same length. Then I will say A and B, the two vectors, are equal. So here you can see I didn't using the initial point and an end point to describe a vector. I actually just draw a vector array and then just labeling it as a vector A or vector B. So in this case, we do not need to always have two letters. We can just using one letter to representing, okay, I'm talking about vector, I'm just going to labeling this one as a vector A. Once we're talking about any vectors are equal, here we're going to talking about can I adding two vectors or can I subtracting two vectors? The answer is yes, we can adding them and we can subtracting them. And then just like when I'm adding a 2 and 3, two real numbers together, I will return back a 5, which is another real number. When we're adding two vectors, we're going to get another vector back. So when we're talking about vectors, it's not going to be that straightforward as 2 plus 3 real numbers, because in real numbers, we only have two directions to consider, either positive or negative. However, when we're talking about vectors, we have multiple possible directions to think about it. For example, I have two vectors, vector A and the vector B. If I'm going to adding them, like for example, adding a head to toes, like for example, I'm adding the A and B together, connecting them, I'm not going to get a vertex because it will bend in the middle of somewhere. So we cannot really have a vertex by just simply putting them together to get like adding the A and B's. Similar things, I cannot really just adding the magnitude of A and the magnitude of B together without thinking about their direction. So how are we going to find the sum of vector A and vector B? Now you're going to connecting A and B, the initial point of A, and then the end point of the B, the terminal point of the B, and connecting them, and that is going to be your sum A plus B. This is a vector. However, in order to talking about vector, I need to have a array, I need to have a direction. So I'm just going to erase. Since we're adding A and B, so that means the sum A plus B is going to the upward direction. When we're talking about, for example, vector A minus vector B, we're talking about vector A plus the negative of vector B. When we're talking about negative sign, here when we're talking about vector, it's talking about the opposite direction. So if I have vector A, and then I'm going to adding the opposite direction of vector B. So opposite direction of vector B is still the same magnitude, same length, but different direction. So it's going to be added up to this to this shape. Now when I'm connecting them, we're going to end up with the diagonal shape. And then just to finish up all the other four sides for the parallelogram. That is corresponding to the black line here. Okay, so once we're talking about addition and then subtractions between two vectors, we can also do multiplication. However, in the vector world, when we're talking about multiplication, vector multiplication, we actually have two types. Here, we're only going to talking about the first type, which is called the scalar multiplication. That means we're going to multiply vector by a scalar, by a number. So if I have a vector, for example, this one, and then I say this is a vector u, then I can find 1/2 of a u. By just drawing exactly the same thing, but half of it. I can also have a negative 2u. That means I'm going to draw the u twice as long, but in the opposite direction. I think my angle is slightly off. Okay, so this is a negative 2u. Since scalar multiplications, that means I can use in any number multiplied by a vector. Can I use 0 to multiply vector? The answer is yes, you can using 0 to multiply the vector, and then the result you're going to get is called a zero vector. That means the zero vector means you have a vector with magnitude equal to 0. And because it's 0, like the magnitude is 0, we cannot really talking about the directions. We're just going to assuming this is a vector with no directions, and then the magnitude is equal to 0.